So what we have here is we have 5 test tubes. You can see in the bottom of the test tubes, I put pieces of magnesium in there. We're gonna put each of the 5 solutions in there: ammonia, acetic acid, distilled water, hydrochloric acid, and sodium hydroxide. So you can see I added some liquid to that. The ammonia water here didn't do much in this test tube here. If we look at it, we can see that there's a little tiny bit of bubbling going on there, but not much of anything to speak of. Okay, the acetic acid, you can tell, is bubbling quite well. The distilled water doesn't, oh, there's a couple of bubbles rising up from there, but not too much going on with the distilled water. The hydrochloric acid is bubbling vigorously. And the sodium hydroxide doesn't look like much. All right, guys, I have all the chemicals in the well plate, and we're gonna check conductivity. So we're gonna put it in the first one. And again, we're not really looking for, does it conduct, yes or no, but the strength of the conductivity. So we can see that that is lit up. The red one is lit up. The green one does not look to be lit up at all. For the acetic acid, if we look at that, by the way, the first one was ammonia water, and the second one is acetic acid. So if we put it in the second one with the acetic acid, you can kind of get a look at that one. This is going to be just the plain old distilled water. And I don't know if you can pick that up, but it is lit up ever so slightly lit up. It's really hard to see this on the video. This is going to be the reaction or the conductivity of hydrochloric acid. You can see it's very bright. In fact, the green one lights up on this one. I don't know if you can see that, but the green one is definitely lit up on this one. And last but not least, we have the sodium hydroxide. And the sodium hydroxide, we can see lights up pretty well. I don't know if you can pick that up or not, but the green one is just ever so slightly lit up, but very hard to see. One of the tests that we're also going to do is a litmus paper test. So what I'm going to do is touch this stirring rod to the ammonia, and we're going to touch it to the red litmus paper and see that it turns blue. We're going to dip it in there again. We're going to touch it to the blue litmus paper and see that it does nothing. Okay. We're going to then move over to the next one, which is the acetic acid, which is this one here. So if I touch it into the acetic acid and touch the red litmus paper, we can see nothing happens. If I touch the acetic acid to the blue litmus paper, we can see that it turns pink. Okay. The next one, the middle one, is the distilled water. If I take the distilled water and touch it to the pink litmus paper, it does nothing. Or the red, it's supposed to be red even though it looks pink. And if I take that and I touch it to the blue, again, it does nothing there as well. So we don't get a color change at all for the distilled water. The next one is going to be the hydrochloric acid. So this one is hydrochloric acid. So if we touch this one to the red litmus paper again, it does nothing. If I take the hydrochloric acid into the blue litmus paper, it turns it to that pink color. Okay, the very last one is the sodium hydroxide. If I take the sodium hydroxide to the litmus paper, it turns it blue. If I take that same sodium hydroxide to the blue litmus paper, we get no change. The litmus paper test was a really good test to tell if it was an acid or a base with just the color change, but this is called pH paper or hydrone paper, and you can see here that it has a list of different pHs on it. So we're going to do the same thing with this test here. So we're going to go ahead in, the first one was the ammonia water. If we touch the ammonia water to here, we can see we get a really nice color. I would say somewhere in the 10 to 11. You can kind of decide. I think the colors show up pretty good on there. Okay, the next one is going to be the acetic acid. So if we look at acetic acid and we touch it to there, we can see we get, it looks about like a 3, maybe a 4, 3. I think a 3 probably. I don't think it's quite a red enough to be a 2, but you can decide for yourself. We get the distilled water If we actually get some distilled water on there, it works better. And we can see that gets to be that 7-ish color. It's kind of that weird, it has a little green tint, but it mostly stays the same color. If we look at the next one, which is the hydrochloric acid, this one here, that one we get all the way down to a 1, that gets a really nice dark red color. You can see that matches really nicely. The 2 has a little bit of orange to it. That definitely doesn't have any orange to it. And then if we do the sodium hydroxide, the very last one, we can see that we get way down to that really nice purple, that 12 color, okay? Maybe 11, but probably better in the 12 range. Hopefully you guys can see that. All right, these are the results of the phenolphthalein test. I'm just gonna take a couple of drops of phenolphthalein and put them in from left to right. I haven't changed the chemicals at all, but this will be in the ammonia. You can see it turned pink really well. This is into the acetic acid, nothing happened. Distilled water, nothing happened. Hydrochloric acid, nothing happened. And then sodium hydroxide definitely turned really, really dark. I don't know if you can see the difference, but it's definitely darker in the sodium hydroxide than the ammonia. Moving on to our last test is universal indicator. So I'm gonna take 2 drops of universal, or maybe just 1 drop would be good enough, and put it into the ammonia. You can see it turns purple. Into the acetic acid, you can see it turns real light pink. Into the distilled water, we're gonna have to redo that distilled water test again. I think I contaminated that when I put some stuff in there. The hydrochloric acid turns a little bit darker red. I know I put more drops in there, but you can see that it doesn't get that much darker there. So this one's darker. And then for the sodium hydroxide, it's a really nice dark purple. Okay, let me quickly add some distilled water to this well plate. Add, there we go. That's the right result. So ignore the one above it that turned slightly pink. Just a small amount of that acid spilled in there when I was pouring it in there. So it should be green. So ignore this well. So it should go ammonia, acetic acid, distilled water, hydrochloric acid, and ammonium hydroxide. Or sorry, sodium hydroxide on the last one, sodium hydroxide. Thank you. All right, this is gonna be for part B. Part B has a mixture. I put 10 drops of the hydrochloric acid in there, 10 drops of distilled water, and 1 drop of phenolphthalein. And we're gonna count the number of drops of base we put in there before we get a color change. So we have 1, and you can see that it turns pink, but as you swirl it around, the pink goes away.
$16, 17,
18. Well, that one was pretty crazy how that one went. 19. So 19 was the one that stayed. This is a lot harder than it looks. So I'm gonna put this back up here on the ring stand. I'm gonna try and speed this up a little bit. We're doing the second one. So 19 on that first one. So we're gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that was a pretty poor drop, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, well that one almost stayed, 23, that one took 23. That was a little bit had to do with the quality of the drops I used on that one, but we had 23 on that one and 19 on the first.
That concludes our acid-base lab. You should have enough information now to fill in the data and do the post-lab questions. Make sure you take the time to read the introduction and the rest of the beginning part of the lab to do the pre-lab. And when you're done with that, you're going to have a test, or actually a quiz, a little check quiz to make sure that you have it all figured out. All right, thanks.